Welcome to the 9th video in my FPS character controllers tutorial series playlist. And in this video, I'm going to be making a third-person mode for our character controller today. I want to build out this template some more, and I have some more stuff planned, so I'm going to try putting out like slightly lower effort videos, because like I was spending a lot of time like going through the script and stuff for my other videos and like just really putting a lot of effort into them, but I can't get as many videos out if I do that, so I'm just going to put out what I have and just see if it helps people just to try that, because I could much more easily make videos if I just make them a bit quicker. So I'm going to be picking up where I left off here with the character controller we created in previous tutorials. You should be able to like adapt these ideas to any character controller, but yeah, basically we're going to put this node third person orbit cam yaw under the character's head node. And then I'm going to create a second node, third person orbit cam pitch. And I nest the pitch one in the yaw. And I'm doing this for a very specific reason, to keep the like vertical kind of rotation and the horizontal rotation separated. And then I'm adding this spring arm 3D node into the nested inside the camera pitch node. And this is a useful node in Godot. It basically just acts as like a raycast that is able to move its child nodes. So any node that you put underneath nested within the spring arm 3D, the spring arm is going to move it to wherever its raycast hits. So like if you ever seen a game where you're like turning the camera and then it kind of like gets closer to your character so the camera doesn't clip into a wall, that's the purpose of this spring arm 3D node. It's just built into Godot. So like if you hit a wall, that camera is going to kind of move forward and get closer to the character to prevent clipping. So I'm just going to call the camera third person camera 3D. And then for these pitch and yaw nodes, I'm going to click access as a unique name. And then to show you what I mean of why we separated the yaw and pitch. So this is yaw, if you don't know, it's like rotating around horizontally. And then pitch, you see if we pitch it like this, it kind of gets rotated in a weird way, because when you mix rotations like that, it's not exactly clear. But here, if I rotate the pitch first and then the yaw, which is what we're going to be doing in code, the kind of pitch and yaw remain separate, and we're able to pitch the camera up and down and then spin it around our character as you would expect for a third-person character controller. One more thing to note, in the spring arm 3D, there's an option to set a shape, and I'm setting mine to a sphere, so that's going to act like a shape cast instead of a ray cast. So it'll be like act like there's a sphere on the end of the ray cast to check for walls. I find a sphere is a little bit less glitchy than just a raw ray. Alright, so next we'll be adding some code to make this camera functional and let us like orbit around with it and switch to it whenever we want. So yeah, you should be able to kind of adapt this to whatever your character controller is, hopefully, if you're not following along with this exactly. But the way I'm doing it in mine, I'm adding this enum with first person, third person vertical look, and third person free look into my character. And then I'm going to add an export variable of the type of the enum. And then when you do this, this is going to add like a little drop down to allow you to easily switch in Godot. Or you can also do it from code as well. So just to make it easy to kind of switch between the different camera styles. And then here I'm adding a setter with this colon, and then you do this like kind of function syntax that takes the parameter v of the new value. You set the camera style variable to the new value. And then we're going to call the update camera function. So this basically just means whenever we update that variable, we're going to call our custom function. Alright, so now that we got that, I'm going to define the update camera function and one other helper function, this getActiveCamera function. So just if the camera style is first person, then we return camera 3D, otherwise the third person camera 3D. And yeah, the reason I have this is because now on my character controller, at least, like there's two cameras, so we're going to be swapping between these. And if you didn't know, you can do that with that current variable on the camera 3D in Godot. So yeah, we're basically just going to be setting one camera to the current like active camera when, you know, depending on if we're in first person or third person mode. And yeah, we're going to do that in the update camera function. So I'm going to write the update camera function, and then yeah, the first thing I'm going to do is just skip it if the character controller is not inside the tree yet for whatever reason. This can happen on the setter variable. That's just like a safety check that I like to do a lot of times. So if it's not in the tree yet, just kind of skip this function, like if it's hasn't fully initialized. But if it has, then we collect all of the cameras, which we just have two: the regular first-person camera 3D and our third-person one. And I just realized this line is like way too fancy using the .any function, which you pass a function into that function. It's .any is a built-in function on an array, which lets you check if any element in that array matches a particular check. So we're checking if any of the cameras are current, or we're checking if not any of the cameras are current. So we're just making sure the camera is not like on another camera somewhere else in your scene. Maybe that would mean you're in like a cutscene or anything. Basically, we're just trying to protect against the character controller stealing focus when it's not supposed to. Could have accomplished the same thing, just do if statement camera 3D current equals false equals false, and then third person camera 3D current equals false. Would have accomplished the same thing, but I just did the any because that's the first thing I thought of. But yeah, all we're doing here is just setting the appropriate camera to be the active current camera that we're viewing the scene from, based on if we're in first person or third person. And then next after that, I'm just going to add the update camera function to ready to make sure it's like updated to the right camera as soon as it enters the scene. And I'm also going to put that in the physics process. I guess you could also put it in process, but I put it in physics process here. I guess it doesn't really matter that much, but the point is to always make sure the camera is updated to the correct one based on the camera style selected. And with that, if you select the desired camera style, then we have third person selected here. We go in game. Now we're in our first person camera, and you can see this spring arm 3D action shooting the ray cast as a sphere, actually. Sphere cast behind us. And then here with this export variable we set, we can easily swap between third and first person camera modes. Alright, so now for the actually moving around the camera, we are going to hop into the unhandled input function, which in my case I already have code for moving the first person perspective camera around. This part captures the mouse if it's not hovered over, or what do you call that? If the current window doesn't have focus of the mouse, then you capture it. And then if the mouse is captured, then we do the normal FPS controls. So I'm just going to modify this a little bit, and I'm going to add the code in for the third person free look for the camera. So we're going to use this third person orbit cam yaw node we put in, and I'm going to rotate it around the y-axis, so spinning it around the vertical axis based on the event relative x, so the x mouse movement multiplied by our look sensitivity. Mine's a really low value, 0.06 I think, because the mouse movement can be quite sensitive if it's too high. And yeah, this is just going to accomplish rotating the third person camera around, kind of horizontally spinning it around. And then we're not in free look, then we'll be in the vertical look or first person mode, and in that case we lock the orbit cam yaw rotation to 0, which will be looking directly forward. So if we're not in free look mode, then we just set the rotation.y to 0 of the orbit cam yaw node. And the rotate y is, we're going to normally, in the first person character controller, you just rotate the actual character with the mouse, so you can spin it around by looking left and right. So that applies both in the vertical free look mode and the first person mode. So everything but the free look, so first person and vertical third person mode, which is kind of like a Gears of War style. It's not over the shoulder, it's directly behind the character, but yeah, that type of third person camera movement. We rotate the camera around still. And then just uncommented this back, this code with the rotate X, that is pitch. So Y would be yaw, I think in every case, so definitely in this case, Y is yaw, so X is pitching the camera up and down. Add that back in for first person, and then for the third person free look, it's very, very similar. So basically the code is like essentially identical here. But for the third person orbit cam pitch node instead of the just a regular camera 3D node. And yeah, so we're just setting the rotation.x, which is going to pitch the camera up and down based on our mouse movement, just like we had here for the first person cam. And then, yeah, because they're like nested, if you do this wrong, you're going to notice it's going to like rotate all weird and your camera might get upside down. But like, you know, so if we like pitch it down, so we're like looking down at our character, and then you rotate the yaw node separately, like it kind of like rotates as you would expect. Like we're rotating the Y of this, like it rotates as you would expect. And like if you kind of do it, like now that we've rotated the yaw, like if we try to pitch it, like see how the camera is like upside down at this point. That's why we have a separate node for yaw and pitch. It's for that reason. Yeah, so undo that. It's gonna be in like default position first here. Make sure it's not like upside down or whatever, because we're just affecting the Y of the yaw node and the X of the pitch node. So we're rotating it around the X axis, spinning it around the X, or spinning it around the Y, depending on which. And then, yeah, just with that, we should have third person mode kind of working. So if you set it to like vertical look, you'll see the character like looks around properly while he's moving. It spins the character, and you can look up and down with it. And then for the free look, same thing. You'll see that it works. We can spin the nodes to view around our character at various angles. But one problem we have with this right now is that like, so I'm pressing forward right now, and it's pretty unintuitive because like usually when you're in third person mode, you want, like if I press W, like it should go towards that orange thing right there, but it's going the direction the camera's facing. So the next thing we're going to do is kind of set him up so he walks in the correct direction. All right, so yeah, in terms of making the character kind of go in the correct direction based on where you're looking for the free look mode, I already have some variables set up here, so you know it might be a bit different on yours, but in my case I have these from previous tutorials I did, the Wischter and cam-aligned Wischter directions. And so first modification I'm going to do here is like just for the cam-aligned Wischter, because we have this get active camera function, I can just replace like anywhere we're trying to get something based on the camera 3D, I do the get active camera instead, and then it will pick the appropriate camera, third person or first person, you know, if we're in third person mode or not. Yeah, so just setting that based on the third person camera. And then for the free look, it's like slightly different. The which direction is going to be determined not on the camera, but on the yaw node. So like just in like the horizontal direction that we're looking, I'm going to use that to determine the direction we want to move. So the which direction I'm using for movement, swimming, ladders, and like a couple other things. So I'm just determining the which direction in my case, and all this code is on GitHub in the description if you want to take a look. So I'm just going to be determining the which direction based on the yaw node. So like whichever way this yaw node, or that's the character, but like whichever way the camera is like rotated around horizontally is going to determine the which direction, which then in my case is kind of split up. So this might be confusing if you're not following the full series, but like, yeah, you can see here I'm using the which direction to determine the player speed and whatnot. And you know, if you want a more in-depth refresher on this, I got my Transform 3D tutorial explanation video And also I go into it in a bit more detail in the first video of this series, the source light character controller video. So yeah, I'm just modifying like the wish directions based on the third person nodes and camera node. And then like that is going to make him move in the right direction that we're looking, but the character is not going to rotate there. So that's what I'm doing here. So yeah, like in the process function, so like every frame, I'm just going to make sure the character is facing the correct direction, like based on where we're moving. So when we're in the free look mode, this is when we have to like change the character's direction, because it's no longer dependent on the way the character's facing. It's just the way the camera's looking. So in process, every frame, if we're in free look and we're moving, or we're trying to move, wishdir.length is non-zero. Yeah, then I'm going to do this here. So if you watch my transform video, how Godot's transform 3D type works, you'll know basis.z is pointing either in front or in back of your character. Mine is in back, so I negate it. So this will be a vector pointing forward for my character. And then for this, I take the signed angle 2, the direction we're trying to move. So like, you know, if essentially we're trying to move like left of the character, this would be like 90 or negative 90 depending on, I don't know if it'd be positive or negative, but like we're trying to do negative degrees to the left, so the signed angle 2 would be 90 degrees. Yeah, so it's signed angle 2. This is a function that works on any vector 3. So forward, the angle from forward to the direction we're trying to move, and it's on the up axis, so like the angle spinning like on the vertical axis. Hopefully that makes sense. And then we're going to determine this rot towards variable. That looks like a little complicated. I'll explain in a sec here. But you can see how it's used right here. We're just like adding the rotation towards to our rotation every frame, and then subtracting it from the third person orbit cam yaw. And the reason we do this thing where we like add and subtract is when you rotate the player, that is also going to end up moving the free look cam. But like, because it's in free look mode, you don't want to like have the free look dependent on like where the player's looking. So what I did in mine, you could also do something where it's like make it a top level transform, but this accomplishes the same thing in that when we're rotating the player one way, we rotate the orbit cam the exact opposite way, or the yaw on the orbit cam. And then that will keep the cam in place and rotate the player towards where we're moving. And so the rot towards variable, this lerp angle function, this like smoothly interpolates between two angles. Is a built-in function in Godot. So we take our current global rotation, and then we take the global rotation plus the amount we need to move towards the way we're moving. And that we're lerping from our current to that rotation. And then here, I just kind of like tweak this until I found something that looked right. Like, so like at a maximum per frame, we like smoothly interpolate by 10%. And then we take the larger number of whichever this is. I found that looked right. So this part right here, so how much we need to add rotation over tau. The reason it's over tau is actually equivalent to half pi, which in radians is 100. Half pi is 180 degrees, so like half a circle around. So like if we're moving the opposite direction we're facing, we have to flip around 180 at maximum. That's the max we would ever have to move around. So yeah, I take like how much we are about to have to move, because this is going to be at max 180 degrees or tau. Yeah, so like if we're fully facing the opposite direction, this is going to be a higher number, and then we'll turn around more quickly. And then and you might like mess with this and see if you can find a smoother strategy to rotate your character, but this is what worked for mine. And so yeah, this is basically gonna smoothly move the angle towards where we're character's moving. And then we subtract, so this will like lerp the old, this will give us the new global rotation.y, subtract it from the current, this gives us the amount we need to rotate towards, and that's what we're doing here. So we add it to the character's rotation, spin him towards, and then we subtract it from the orbit cam yaw to keep it stationary. And with all that, now you see he will start looking wherever we are moving. And in this free look mode, this works a lot more intuitively. You're going to see he is looking in the correct direction of wherever he's moving now. Alright, so that pretty much takes care of all of the logic. I'm actually going to add a couple little more pieces of code to make it fit in with everything else I already added for this character controller. For example, in the ladder physics movement code, I have it dependent on the camera 3D, but what I'm actually going to do is just change it to the get active camera function. So like anywhere I am like doing something dependent on the camera look direction, I'm just making sure like I'm actually using the actual camera that is the player's looking through, based on, you know, the third person camera or the first person camera. So like if we're in free look mode, the ladder will still work intuitively based on the look direction. And then I'm also going to add some code into the controller look input. So yeah, I just have it like moving the player and camera left and right or up and down based on the X and Y of the controller analog stick input. And then yeah, I'm going to change it up a little bit. So yeah, in vertical free look, or in third person vertical look, or first person, we do the normal left and right rotation. Otherwise, we do the orbit cam yaw node left and right rotation. So like in free look, you can like kind of look around the camera with the right analog stick, as you would expect, as is like a common behavior in a lot of games. And then here I'm just going to add I'm going to match the orbit cam pitch rotation.x to the regular camera 3D rotation.x to make sure they're always like synced up if you're using the controller, so they don't get out of sync. And that's pretty much it. That is the tutorial. I wanted to do this tutorial to set up for the next one where I'm adding like a 3D model, because I wanted to be able to like actually see it when you're in third person mode, so you can see like the 3D model that's on the character controller. I just made a 3D model of this like robot dude. Just uploaded a video on that if you haven't seen it. So yeah, that's pretty much it. There's third person mode working for you, and hope you enjoyed. And thanks so much for watching. Make sure to rate, comment, and subscribe. I am going to try to build out this character controller some more, I think. I'm still kind of trying to figure out what videos to make on this channel, because like I like the ones that take a lot of effort, but they take a lot of time. Yeah, so I'll see. I'm hoping to build out this character controller some more, which I think people wanted, but I think I'm going to do it like kind of more casually and just kind of... I have like a bunch of stuff I already made for it, so I'm just going to kind of do the tutorials on that properly and like explain what I did and whatnot. The next one should be the adding the player model to it. I have like a player model that I created, the desert droid robot I did a 3D model of, so I'll be adding that to the character controller, and that is the next video I'm planning. So rate, comment, and subscribe, and thank you for watching.